In this lesson, we'll be proving the formula for sum to n term of a geometric series. So, the formula is given as Sn is equal to ar to the power of n minus 1 divided by r minus 1. So, a stands for the first term, r stands for the ratio, and Sn stands for the sum. So suppose we have a series 2 plus 4 plus 8. Okay, this is geometric. How do you know that it's geometric? Okay, if r is equal to, if t2 over t1 is equal to t3 over t2, therefore it's geometric. Let's prove it. 4 over 2, is it equal to 8 over 4? Well, yes, both gives us 2. This means that this is a geometric series indeed. So, there's something important which I want to illustrate here. So, we are given the series 2, 4, 6. No, it's 2, 4, 8. Sorry. So, we are given the series 2 plus 4 plus 8. Let's add the last one, 16. So, how do you move from T1 to T2? Well, you multiply it by 2 here. And how did you move from T2 to T3? We still multiplied by 2. And how did you move from T3 to T4? Well, we still multiplied by 2. This means that T1 is equal to 2 in this case. Okay? And T2 is equal to 2 multiplied by R, which is 2. T3 is equal to 2 multiplied by R multiplied by R. Can you get it? To get 8, we said 2 multiplied by 2 multiplied by 2, and we got 8. So what I want to illustrate here, that is very important and you must understand it when you will be proving this formula, is that T1 is equal to A. T1 is equal to A. T2 is equal to AR. T3 is equal to AR squared. I hope you understand this. This is very important so that you can be able to prove this formula. So we're going to start. We're going to say that Sn stands for the sum. It's equal to T1 plus T2 plus T3 plus, they go further up until the last term, which is Tn. We said Tn stands for the last term. Okay, so we're going to say that Sn is equal to, what is T1? T1 is equal to A. What is T2? T2 is AR. T3 is AR squared. And they go further up until the Tn of a geometric sequence or a geometric series was that it's AR to the power of n minus 1. Check this in the video for how to find an equation of a geometric sequence. You'll get this, that Tn is equal to AR to the power of n minus 1. But this is something important that we need to note here. Okay, we need to know what term is before the last term. This term is AR to the power of n minus 2. I will illustrate this at the end of the video. For now, just grasp it this way. And this is our first equation. Let me highlight it to show that it's our first equation due to lack of space. So this here will be our first equation, equation number 1. So now we're going to get equation number 2. So to get equation number 2, we're going to multiply equation number 1 by R. How so? Okay, what is Sn times R? This will give us R Sn. What is A times R? Will give us AR. What is AR times R? Will give us AR squared. What is AR to the power of 2 multiplied by R? Will give us AR to the power of 3. Plus, then we go to this one. the term that comes before the last term. Let me illustrate this. So it's AR to the power of n minus 2 multiplied by R. Let's hide the A and pretend as if we don't know it exists. Do you still remember when we were doing the laws of exponents? We said that when you are multiplying the same bases, you keep them and you add the exponents. So we're going to keep the R in this case, because we're multiplying R to the power of 1 and R to the power of n minus 2. This is going to be n minus 2 plus 1. I hope you can see this. So this is going to give us a R to the power of n. Negative 2 plus 1 gives us negative 1. This means that the term that we're looking for is AR to the power of n minus 1. I hope you understand this. So here we are going to have AR to the power of n minus 1. It's AR to the power of n minus 1. Plus, now we are going to multiply the last term. We're going to multiply the last term. What is the last term? Is this. We're going to multiply it by R as well, because we said we're multiplying everything in the first equation by R. So we're going to have AR to the power of n minus 1 multiplied by R. And we're going to keep the R and add the exponents. And the 1 cancels the 1. We're left with AR to the power of n. You see? So here we have AR to the power of n. So that is it. That is it. We have multiplied the first equation by R, and this is what we have gotten. And this is our second equation. This is our equation number 2. What we're going to do here is that we're going to say equation. Okay, first of all, what we do here is that this term cancels this term. This one cancels this one because they are the same. AR to the power of 3 will cancel AR to the power of 3, which will come here. And this one will cancel something that is here. And this one will cancel this one. And what we are left with is Sn and A. We are left with Sn and A, Rsn and AR to the power of n. So that's what we are left with. We can see that Sn is equal to A. That is from the first equation. And then Rsn is equal to AR to the power of n, and that is from equation number 2. So what we're going to do here is we're going to say equation number, let's see, they said we must prove R to the power of n minus 1, and below we must have R minus 1. So here an examiner can ask you to prove this formula in 2 ways, and I need you to be able to do it. An examiner can say prove that the formula is given as Sn is equal to A multiplied by R to the power of n minus 1 divided by R minus 1, or prove that Sn is equal to A multiplied by 1 minus R to the power of n divided by 1 minus R. So in this both cases, examiner just flipped the Rn minus 1. This minus is not on the exponent. Don't lose it. It's not on the exponent. The minus is actually here. It's R to the power of n, then it's minus 1. So if they say do it in this way, at the end below you must have R minus 1. We use this formula if R is more than 1, if the value of R is more than 1, and here if the value of R is less than 1, we use this formula. But this case we are required to prove this one, so we're going to prove it. Let's see. So what we're going to do here, we're going to say equation number 2 minus equation number 1. We're going to say that equation number 2 minus equation number 1, that is Rsn minus Sn is equal to A R to the power of n minus A. If they said prove the other one, you're going to say equation 1 minus equation 2. Okay, so we're going to take out a common factor of Sn, and we'll be left with R minus 1. then it's equal to, it's a, then it's r to the power of n minus 1. We've taken a common factor of a. Then what we're going to do here is we are going to divide both sides by r minus 1. We divide both sides by r minus 1, and we divide both sides by r minus 1. This one cancels this one, and at the end we have Sn is equal to a multiplied by r to the power of n minus 1 divided by r minus 1. And this is the formula. Make sure you understand how to prove this formula. You can follow the steps on your own. If you don't understand, feel free to ask in the comment sections. So here I said I was going to illustrate what happened on the first equation. Okay, so I didn't forget. We said the last term was ar to the power of n minus 1, and we wanted the term that was here, and I told you I was going to show you at the end of the video. Okay, so to get this, remember that the first term was a, and the second term was ar. The other term, the third term, was ar to the power of 2. So let's focus on r alone. Okay, so suppose we have this one and we are looking for this one. How did we transform this one to be this one? Well, we subtracted 1 here. Okay, we subtracted 1 here to get this one. So even here we're going to say ar to the power of n minus 1, which is this one, and then we subtract 1 from it to get the term that is here. And we know that ar to the power of n minus 1 will give us minus 2. That is ar to the power of n minus 2. And that's where this thing came from. Thank you for watching.